Okay, in this presentation we are going to look at Project Euler question 2. Project Euler is a series of mathematical programming exercises for people to test their skills at mathematical programming using a variety of programming languages such as Python or Julia, MATLAB, and so on. We are using Julia version 1.6.1 and we are using Jupyter notebooks. Now, so this presentation should be fairly quick really because it's very straightforward. Now, I'm sort of assuming that you might be familiar already with the Fibonacci sequence. Each new term in the Fibonacci sequence is generated by adding the previous two terms. There's a base case with the first two terms be 1 or 2, 1 and 2. And then the first 10 terms will be 1, 2, 3, 4, 5, 13, 21, 34, 55, and 89. Okay, we'll go with that definition there. There's always a base case to sort of start off these recursive functions. Okay, in other examples, there might be 1, 1, 2, 3, 5. So let's just go what we have here and just take it as face value because we're interested in the programming, not the mathematics. Now, so by considering the terms in the Fibonacci sequence whose values do not exceed 4 million, find the sum of the even valued terms. Okay, so just actually, how do we test if a number is even valued? Actually, I'm going to just put that in there. See if we can test the remainder and when a number is divided by 2. Okay, so this here will give us the remainder of what we get when we divide 5 by 2. Okay, and it will be 1. Let's do it for an even number. We will get 0. Another even number, 14, 0. So essentially, this is a little test there to see if a number is odd or even. That's fairly straightforward. Just check if the remainder is 0 if you are dividing by 2. Okay, good. The next thing we're going to do here is, we don't really need to do this, but this is handy to do. Okay, what we're trying to do here is use this sort of mathematical notation here. Special numerical notation for large numbers that are powers of 10. So what we have here is 1 times 1 E3, and essentially that is 1000. So there we go. There are 3 zeros there, so that's what that 3 comes from. Just as a remark, you need the 1 at the start because this just makes no sense. 1E3. Okay, so that is the engineering notation, I believe. There we go, and that is how we would so those two numbers are equivalent to each other. So if you're dealing with very, very large numbers like a billion or 100 million or so on, and we know the power of 10, great, that's a simple way of doing it. So if you want to express 4 million without trying to sort of test out all the zeros, but we know there should be 6 zeros in 1 million, we can write it like that there. So that is equal to 4 million there. Okay, 4E6. Okay, if you want to write 1 million, just remember to have that 1 at the start. Okay, so what we're going to do here is write a function, and we're going to declare our function using this command function. We're going to give it the name Euler. Okay, Euler 1. You could call it Fibonacci as well, or sorry, Euler 2. Okay. I'll just call it, yeah, we'll call it Euler 2 because just for the sake of clarity going forward. What I'm going to do here is establish my base case, which is the first two pair of values, 1 and 2. Now, a little bit of thought is required here. I'm going to initialize my total here as 2. Okay, that is the sum of the even numbers here. Okay. So it's just 2 because that is the sum of the even numbers from this pair of numbers. Okay. So a while loop, while b is less than 4 million. Essentially, what we're going to do here is go through each successive pairs in the Fibonacci sequence. So we're just going to consistently update them, each successive pair, by replacing a, b with b and a plus b. Now, if you just sort of take a moment to think about that, that makes sense. Okay. Now, if b is divisible by 2, okay, we add b to our total. Okay. Now, just to be clear, what happens is that the first case, the first pair is taken care of. Okay. So we just have to add 2 to the total there. So the base case has already been taken care of. The total is already 2. So what happens in the first iteration of this, AB is 1 and 2, and that will become 2 and... what's the next one? Sorry, my mind has gone there. 2 and 3. Okay. So essentially what it will do then is it'll test B, the new B, which is 3, to see if that is 0. And if that is the case, it will update the total with that. See if that is an even number, and if it is an even number, it will update the total. Add that number to the total. Okay. So this is just an interesting way of simplifying the syntax here. This is essentially equal to total equals total plus b. Okay, that's essentially what we're doing there. It's just for the sake of simplicity, we can write it like that. Okay, just a simpler, more condensed syntax. So that is it. That is the function we need. So we put in all our end statements, and then we return our total, and then the end statements for the if and the while. Okay, my indentation is a little bit funny looking there. And there we go, Euler 2. We don't have a function for this because this is not, this is only going to use this function once, so we don't have an input for it. We're not going to change it that much. No. There we go. Sorry, I just need to reset it there. So the answer is 4,613,732. Okay.